Assalamualaikum and a very good day to all of you. I am Dr. Nadira Binti Darus. So for the synchronous class, actually this is our first class for my part, which is the final part for this subject. Okay, the first two parts have been covered by Associate Professor Dr. Rozana, and also the second part has been covered by Dr. Heruzan. So I will cover the rest of the topic, which is focusing on the construction noise, right? Okay, so I think without further delay, let us proceed. Let me proceed to the class, right? So first of all, again, this is actually we are in week 14, right? So last week or previous week should be supposed to be my first class on week 13. However, I'm so sorry because I'm unable to conduct the online synchronous class. So all of you may refer to the e-learning for the notes, and for the video recording, I will try to upload the video as soon as possible. I'm so sorry for the delay because there are some technical issues, all right? So I will try to upload together with today's class for the video, right? Okay, so again for today, we will cover on the other subtopic of construction noise management, okay, which is construction noise propagation. So I hope all of you can grab the content of this topic and also subtopic. Okay. So currently there are total 31 of you. Right. So maybe the rest of you will join later on. Okay. I noticed that some of you we have met in another subject, okay, for another subject, and also maybe some of you already know me from previous semester, right? Okay, so I hope all of you are in good condition. Okay, so is everything okay? How are you, everyone?
I'm good, Doctor.
All right, thank you. So I really hope that all of you are in good condition, okay, so that we can continue our class. Okay, also goes for other class that you have registered for the semester. Okay, so I think without further ado, let us proceed to this topic. So, okay. So for today, I will cover on this one, construction noise propagation. First of all, okay, we have some quick check on the regarding the topics, okay, and then the assessment and also subject registration. Okay, for the topics, supposed to be I will cover these three, and for the last week, for the previous week, this is the first topic for construction noise management. So basically on previous topic, later on I will conduct some brief revision, okay, so that we try to revise again, we try to recall again the what we call the topic and also the sub-content of this topic, right? So overall, this topic is more on fundamental and also basic part of construction noise, okay, which related to issues and management, right? So for today, we will continue for this one, as I mentioned just now, construction noise propagation. All right, basically in total, this is the total week, and I hopefully by next week, which is week 15, we are able to finish everything regarding this topic. Okay, however, if we are still have something to complete, I try to what we call maybe to have extra recording for extra class. So hopefully we try to finish all of this within by next week, right? Okay, for the assessment, this one only for the carry mark, okay, excluding the final exam. Okay, for the assessment, previously, I think Dr. Rosanna and also Dr. Halusan have covered their part. Okay, for my part, there are another 20% of the carry marks that will contribute for this topic for my part. So this 20% will be completed for your group assignment. Assignment. Okay. So I will share the details for the group assignment through e-learning. Okay, as soon as possible. Right. Another thing regarding the final exam. Okay, so supposed to be final exam will be 100% mark. So the distribution for this 100% will be divided into 3 parts based on the based on 3 lecturers, right? So the first part by Associate Professor Dr. Rosanna will contribute for 30%, the other 30% for Dr. Harusan part, and then the last 40% will be contribute for this topic for one part, right? For this final part of construction noise, right? So I hope all of you quite clear on this assessment so that all of you are able to score for the subject successfully, right? Okay, so far, do you have anything to ask regarding these topics and also assessment? Is everything good? Is everything clear? All right. So again, for my class, okay, if you have anything to ask, if you have anything to clarify or discuss, you may do so, right? So that throughout the class we can have the discussion session. Okay. So similar goes to my other subjects or my other class. I'm preferring for us to have discussion, or if you have anything to we got any query, any question to ask, just ask me during the class. Okay, you may interrupt my explanation, right? Okay, so another thing for the quick checking is related to subject registration. So based on my record, supposed to be we have these 2 class. The first one for master class, and then the other one for undergraduate. SKA5133 section 01, both section 01. So based on my record, there are 11 of you who registered for MKAM1133, and the rest 29 of you registered for SKAB. Okay, so I would like all of you to double check this subject registration so that you don't have any problem relating to your final exam. Okay, for the purpose of final exam, this is very important because based on previous semester, it happened that some of the students are not aware which subject they have registered, and they are sit for different section. Okay, so we try to avoid that kind of situation. So that's why I would like all of you to double check again your subject registration record regarding this class and also the rest of the class. Okay. So I think that's all for the group checking. This one for the purpose of all of us aware on our condition, okay, regarding the subject, regarding the topics and assessment, and so on. Okay, so now we will proceed to the next part. Right? Currently there are 32 of you. It's supposed to be the total with right? For the student for this class. Okay, so before we proceed to this topic, okay, I think it's better for us to have some brief recall, okay, so that later on, once you refer the notes, when you refer the video recording, you can relate all of these. All right, so basically for previous week, week 13, this is some of the sub-contents or subtopics for the first part of my class, which is focusing on construction noise and construction noise issues and management. Okay. So the first part for the previous topic is related to the construction issues itself, right? So it has been divided into two parts, which covering the worldwide issues and also local perspective, focusing in Malaysia, right? So you can go through the lecture notes, and if you have anything to ask, you may ask me, right? Either through WhatsApp or through email. I'll try to assist all of you. And then that's for the introduction or overview here. We have overview for the topic or introduction part. Then we continue to the next subtopic of potential construction resources. All right, this one also an important element or important part for this topic, so that you can differentiate, you can identify what's actually the sources of construction noise. Because for your information, there are several other types of noise, so that we can differentiate each of these type. Whereby later on I will explain on the type of noise itself, right? So I hope that all of you can understand all of these, okay, all of these content. And then after the noise sources, you also need to know the effect of noise, right? Okay, again, as I mentioned previously, all of these subtopics are more on fundamental, more on the principal part. However, this is very essential so that you know the basic of the construction noise. Okay. In terms of the noise effects, if we refer back to the lecture, it has been divided into three types. Okay, physical, psychological, and physiological. So you may do your own reading on that. And then continue to that, we have another subtopic on noise loss and regulation, right? So I would like to remind again, we are focusing on construction noise. So we need to know which laws or which related regulation and also guidelines suitable for us in managing construction noise, because we have several other types of noise or other types of situation. However, we need to determine which regulation, which guidelines to be used for each of the condition. Okay, and the last part for previous topic is on construction noise mitigation or control, meaning that how we conduct or how we control the noise itself. So we have several mitigation. We try to revise or you try to do your own revision on this, all of these subtopic. Okay. So far, is everything good? Okay.
Good, Doctor.
Sorry.
Okay, Doctor.
Okay. All right. Okay.
Okay, Doctor. All things clear.
All right. Thank you. Thank you, Rai. All right. So that's all for the quick recall. Okay. Just a brief recall for previous topic. Okay. Hopefully all of you are able to understand all these basic parts of the fundamental part for this topic of construction noise management. Okay, for today, we will continue to the next subtopic of construction noise, which is construction noise propagation. This is the list of the subtopic that we are going to cover today. Okay, starting from the overview or introduction part. Most of my class, I will start with the introduction so that all of you are able to have a good view what's actually we are going to cover. Okay, so that's the importance of the introduction or the part for each content or for each topic. Okay, then we try to cover on characteristic of noise, types of noise, because on previous what we call on previous week, okay, on previous topic of week 13, we should cover on issues, okay, the general part of construction noise. So now we are going in detail regarding the noise management itself. So in order for us to have a proper and efficient noise management, effective noise management, we need to know all of this, right? We need to understand the principle, we need to understand the characteristic of noise itself, okay, types of noise, and then the rest of these subcontent which relating to the sound and also noise. Okay. Now we will proceed to the introduction of sound and noise. All right. So basically, this is a brief overview related to sound first. We are going to get on sound first, and then later on we will try to cover what's actually noise refers to. Okay. So I'm sure that maybe some of you or most of you already know about what's actually sounds refers to. Okay, however, we try to I try to share again, okay, what's actually the definition of sound and also noise. Okay, so in overall, sound itself related to physical, related to physics or science physics, right? So sound will be produced when air is disturbed, okay, which is the physical principle. So anything that vibrates in air creates a sound or pressure wave, either high or low. Okay, you can see here based on this illustration, we have based on this animation, we have this this turning fork. Okay, we have here the compress and also the reflection line here section, which represent the high and low region for the pressure. So the sound itself, we note it as sound pressure level. So later on throughout our class, I will explain more on this SPL or sound pressure level, or the what we call the symbol maybe LP, right? The other important thing related to sound itself is measurement unit. Okay, you need to know that for the sound, the worldwide or the what we call the general use related to the measurement unit, use decibel. Okay, instead of Pascal, we use decibel to represent the unit of sound. And related to this one, you need to know that sound is using dB scale, okay, decibel scale. For sound is logarithmic. So this one will be related to your calculation later on. Okay. So for your information, the subject or this this part, for my part, we at the end we have the calculation part. So for the earlier part, we need to understand the fundamental, we need to understand the principle, and then we try to relate all of this to the calculation part later on at the end of the class or my part, right? So you need to know that dB scale is a logarithmic scale instead of arithmetical. Okay. Okay. What's we have? If we refer on our right side, we have this figure showing the pressure. Okay. The pressure region. Okay, we have here high pressure region. For which represented by condensation. So again, condensation area of region represent high pressure of the sun. Okay, and then reflection showing the low pressure. So we have both here condensation and also reflection. This is just a basic what we call principle of sound itself, right? So I hope all of you can understand this. Okay? We maybe most of us have learned this one on in our secondary school maybe for this, right? Okay, now next one we are going to cover on overview of noise. Okay, the main reason why I would like to highlight again the overview of sound and noise because we need to differentiate these two terms, right? Sound and noise, because these two terms, if we refer back, they are interrelated. However, they have their own definition. Okay. So that's why we need to know the exact definition for each of these terms. All right, so that we can have a clear view for both of these sound and noise terms, right? Okay, so in overall, noise itself refers to any unwanted sound. Okay, so that's why I mentioned just now noise and sound are both interrelated. However, noise are more on negative, negative perception of sound, which irritates human ear and may cause annoyance. So anything that irritates, any sound or any sound that irritates or that annoys our ear, our hearing capability, it will be categorized as noise. Okay. And then another thing is that noise can be seen, smelled, or tasted, but it is everywhere. It is around us. Okay, both indoor and outdoor. It exists in our daily life. Okay, yeah, that's why they are around us, okay, both indoor and outdoor. Okay, because in our life there are so many sources of noise. All right, for example, we have indoor noise. Okay, there are too many sources of noise actually. However, the perception of noise itself, depending on the individual. Maybe some of us will consider the loud sound itself as a noise. However, maybe some of us just uh, what we call just recognize it as a normal sound. Okay, for example, if we are hearing, we are listening to the high music. I mean the loud noise, like loud music. Okay, maybe some of us it's just a hobby, so that's why that one will not become a noise today, right? So that's based on or depending on individual perception. And the noise itself is quite difficult to be managed or regulated. Okay. However, we still need an effective noise management so that it will what we call it will help us in terms of sustainable living. Okay. It will protect our living environment, right? And as cities grows, the noise management itself become a greater challenge since more people live in proximity which is close to each other. So that's why we have more sources of noise happen around us. And then according to World Health Organization, noise must be recognized as a major threat to human well-being. Okay, as we know, as all of us know, that we are moving towards sustainable and green living. So that's why noise management itself become part of the significant, what we call significant alternative that we need to manage. Okay. All right. So I think that's all regarding the overview of noise. So let's see the next one. All right. So this one again still related to the introduction part, however, this one focusing on construction noise itself, right? So as I mentioned, there are several types of noise that we are going to cover later on. Okay, I will share also on that. So construction noise itself is unwanted sound, again, unwanted or any what I call unwanted any annoyance, any irritation generated by construction activities that irritates human ear. So again, anything that irritates us, irritates the individual, will be categorized as noise. Okay, for this purpose, we are focusing on construction noise. All right, so in overall, it has the same physical theory as the sound, which is caused by the collision of molecules that refract and compress due to changes in abrasion. This one I have mentioned in the earlier part. What actually sound refers to. Okay, so next one. All right, this is just a continuation for the difference between sound and noise. So both of these figures represent the illustration for sound and noise. So if we look on our left side, we have pure sound here and also noise. Okay, so pure sound is what we call a good sound perceived by human ear. Okay, that one will not disturb the condition of our hearing capability. Okay, for example, musical note, which is a harmony sound or anything that will what we call will be a good sound for our hearing. Okay. However, if we look at here, this is the illustration for noise. So one of the type for noise generation is due to hammering. Okay, we can see here that the pattern for the hammer, which is categorized as impulse noise, okay, have this kind of pattern, right? So that's why this illustration represent noise because it has what we call not a uniform pattern here. Okay, that's why it will disturb our ear. It will disturb our hearing capability. Okay, as compared to the previous one. All right, that's the general illustration between sound and noise with the difference. Okay, in terms of the difference between these two. Okay, so before I proceed to the next one, so far, can all of you understand this? Or am I going too fast to explain the what we call the difference, the principle of sound and noise? Okay. Right, so hopefully all of you are able to understand, okay, to differentiate this one. Okay, so the next one we are going to look at on the characteristics of noise. So this one quite important because these three are the main parameter or the main characteristic of noise, which consists of the first one we have wavelength represented by lambda, and then second one we have frequency F, and then last one we have amplitude P. All right. So we are going to briefly cover this one, all of these three characteristics. Okay, for the first characteristic, wavelength is actually a physical distance between two amplitude peaks. Okay, so for the next slide, I will show you the diagram or the figure to make it all of these characteristic more easier to be understood. Okay, so it can be minimal or maximal because it has the high peak and also lower peak, right? And for the wavelength, it will be measured in meter, right? So this is the units used for the wavelength measurement. And wavelength actually shows a tone sound. Okay, so later we will refer to the illustration, the related figure for this characteristic. And for the second characteristic, which is frequency, it is actually a number of waves per second. Okay, it will be measured in hertz, Hz represented by Hz, hertz. And if we relate to the construction noise itself, as we know, construction noise are a complex mixture of noise level variation, meaning that in construction activities, we have so many sources of noise. Okay, for example, let's say we have earthwork activities. So for sure, for that activities to be completed, for that activities to be finished, we need to use some or several types of equipment or plant and machineries, such as the obvious one, we need the excavator, we need the lorry, and also compactor maybe. So that's why each of these individual construction equipment or plant will generate different sources of noise. Okay, so that's why the nature of construction itself are quite complex. Okay, so we need to properly manage, we need to properly plan and also manage in terms of the noise generation itself, right? So all of these sources of noise are from complex frequency region. Okay, later on we try to cover on this one, frequency. And the last characteristic of noise, or the third one, related to the amplitude. So overall amplitude associated with noise level received by the human ear. So it will related to the noise generation that affect the human ear. So the higher the amplitude, the higher the sound pressure level. That's the principle. Okay, let's try to understand this basic principle, this basic characteristic, so that it is easier for us to relate to the equation, to relate to the application of construction noise management. Okay, so the next one, still on part of characteristic of noise. So this one more on sound wave generation. All right. This is the figure that I mentioned just now to represent the wavelength here, lambda, and then we have amplitude for P. And for the frequency, we can refer to this one, air compression, and then air refraction. Compression or condensation, we add the term for compression, condensation, and this one, refraction or refraction. Okay. So both of these regions showing the frequency region. Okay, so this is just an illustration showing the condition of noise generation related to its principle or characteristic. Okay, on our left side, we can see that this is a product crane, one type of the construction plant or machineries conducting the or carrying the piling activities. Okay, as we can see here that we have drop hammer, which is one type of equipment or machineries that generate significant noise level, right? So this from the sources, the noise travel to the receiver, okay, nearby receiver. Can be the construction workers itself or the nearby resident. Okay. All right. So basically this again you need to refer to the previous topic or previous lecture note. We have the concept of source, path, and receiver. Receiver. But then before the bad writing. Okay, so we have here source, path, receiver concept for the noise transmission. Okay, so that you need to understand this one so that it is easier for you to relate with the noise mitigation. Okay, for this case, for this figure, just a basic example, we have this one for the source of noise due to the piling works. Okay, this will be the source, and then the path will be the transmission path from the source to the receiver, nearby receiver. Okay, this receiver itself for sure will be construction workers or nearby resident from the residential area. Okay, so I hope that all of you are able to understand the concept, to understand the characteristic and also principle. Okay, so again, if we look at back for this figure, we have wavelength represented by this red line here. Okay, so wavelength, this is one complete cycle showing the wavelength, and amplitude represented by this region. Then we have this upper part and the lower part, right? Hopefully, all of you can understand this one, right? Okay, we are moving to the next one. All right. Related to the characteristic of noise, just now we have covered on three main parameters of noise: wavelength, frequency, and also amplitude. Okay, now we are going to look at all different types of frequency. Okay, so for your information, there are three regions or three types of frequency. The first one, we have low frequency for represent the low region, and then we have medium, and for sure the last one we will have high frequency. Okay, so if we look at here 10 hertz to 1000 hertz or 1 kHz here, this is to represent the low frequency, continue to the medium frequency from 1000 to 4000. Okay, and the last one we will have high frequency region, 4000 up to 20,000 or 20 kilohertz. Okay, all right. So this is the types of frequency based on the region. Okay, and the types of frequency can be represented by this application. Okay, if you can see here, there are three main category here. We have infrasound, acoustic, and also ultrasound. Okay, we have three here. So acoustic itself will be the main category because it related to the human hearing capability, 20 hertz up until 20 kilohertz. Right, this is the region that we are focusing. Okay, instead of we have infrasound and also ultrasound. Okay, so this is for your what we call additional knowledge. Okay, for different types of frequency. Okay, so the next one, before we look at on the relationship of these first three parameters, Okay, so far, can you understand this one? All of this?
Yes, doctor.
Right. Thank you. Okay, if you have anything to ask, you may ask me during the explanation, okay, so that we have the discussion. Okay, before I forgot, any of you have ever involved in nurse management, have attended any class apart from my class? Have you ever have any experience, maybe on-site experience to conduct nurse measurement? Nobody? Maybe someone here. Oh, it's okay. They are just asking for the purpose. If any of you have previous experience okay related to the nurse measurement, so that you may share your experience, so we can have a sharing session. Yeah, okay, together with the discussion. Okay, so now I think just proceed to the next one. Right, we have characteristic of noise still on the same sub-content for characteristic of noise. However, we are going to look at on the relationship. Okay, focusing on the equation for this related noise characteristic. Okay, for this one, we are going to look at on the relationship between lambda and frequency. So what we have here is that we have lambda or wavelength equal to the speed of sound c represented by c and divided by frequency f. Okay, so as we can see here that the higher the wavelength, okay, or the greater, okay, the larger the wavelength, the frequency will be low. Okay, so for example here we have this illustration. The bigger the wavelength, the frequency will be low. Okay, it's related back again to the back to the condensation just now and also reflection. Okay, so this lambda represent the distance between two consecutive points which are vibrating in phase. Okay, so this one, you can see here that this is the lambda, the wavelength between two consecutive points. Okay, C, speed of sound is depending only depends on the medium the wave are travel through. Okay, different wave of sound travel will cause different speed of sound. Okay, and the last one we have for frequency. So this is the basic relationship between lambda and f. Okay, what we need to know is that the greater the wavelength, the lower the frequency. Okay. The next one we have interpretation or explanation related to the previous equation. So wavelength or lambda again is an important characteristic for acoustician in treating the room environment or noise barrier. Okay. So for your information, for the acoustician, for the anyone who would like to mitigate or like to control the noise, they need to know the wavelength so that they can treat the room. For example, we have a poor classroom condition. We have, for example, we have too much echo in that room, in that classroom. In terms, once we have a higher echo in a room, it's quite difficult for the receiver to receive the information. If, for example, this is the classroom. It's just a simple illustration. We have two persons in this room, okay, talking to each other. Okay. So if the condition or the acoustic condition of this room quite poor, okay, meaning that they have too many echo, Basically, echo caused by the hard surface of the room. For example, this is the hard surface due to floor, and then we have concrete wall here, concrete floor and concrete wall, and these two are communicating to each other. However, due to higher echo, the sound or the information, okay, from the first person A to B are unable to be delivered well, okay, because the sound will be reflected or dispersed throughout this room. That's why we need to know wavelength, okay, as an important characteristic of the noise itself, so that the acoustician can manage the noise. Okay, that's actually how we relate the principle to the application or the actual mitigation. Similar go to the noise barrier. In any case, if we try to cut the noise transmission, for example, from this point, receiver, noise source to the receiver, okay, this one receiver, and in between we try to cut this noise transmission using noise barrier. So wavelength plays an important characteristic or important parameter for the acoustician to mitigate the noise. So later on, I will share also on the noise mitigation part, so that you will have better view for this principle and how actually it's related to the application. All right. So just additional information. Sound propagates at a speed of approximately 340 meters per second in air. Okay. This one, as I mentioned just now, the higher the frequency, the shorter the wavelength, and it is vice versa. Right. Vice versa. Okay. The longer or the larger the wavelength, the shorter the frequency. Okay. That's the main principle. Okay. This is just an example. What we call in terms of the management of application. At, for example, at 20 Hz wavelength, about 70 meters, thus an object must be larger than this dimension to block the sound. Okay, this one relates to the noise barrier application. Just for your information. Okay. And then the other one relates to the low frequency, which produce low tone sound. Okay, for the actual application, it relates to the equipment or construction equipment here. Okay, for information, most of the construction equipment with low frequency generation are due to lorry, okay, excavator, we have dump truck and so on. Anything, any equipment or any machinery similar to this one, lorry, excavator, compactor, and so on. Okay. Due to its longer wavelength, it's hard to provide mitigation. Okay. This is what we call this is actually relates to the actual noise mitigation. All right. That's the characteristic. This is the example of the construction plant or machineries with low frequency characteristic. Okay. The frequency, this is the sample just now, example. And then again, for the characteristic of noise itself, we need to know we need to cover on this one, frequency analysis, right? So again, analysis of frequency spectrum is very important for the evaluation or determination of suitable noise mitigation. So once we are able to identify or analyze the frequency, we know the sound is categorized for low frequency region, so we can propose suitable noise mitigation, right? And then this is quite important because frequency of noise compensation is in the range between 20 to 20 kilohertz, in which human ears can detect. Okay. Because this range or this what we call this category of frequency region is basically for human hearing capability. So that's why our ear, our ears is capable or sensitive to this frequency region. However, the most sensitive region is between 3 to 4 kilohertz, 3,000 to 4,000 hertz. This is just for your information, okay, so that at least you know what's actually frequency and what's the purpose of frequency itself relates to the noise management. Again, for measurement purpose, frequency of sound are divided into this. Okay, one octave, okay, 1/1 octave, and we have 1/3 band. Okay, this one I will share maybe in our next class, okay, related to the noise measurement. So just for your brief information, frequency can be divided into this category, especially for the measurement purpose. Because as we know, frequency itself consists of a wide range of the or wide bands for each of the sound. So to make it simple for the simplicity purpose, we divided this frequency into its several category of octave bands. Okay, so later on I will share on that. Okay, this is how actually frequency band looks like. Okay. All right. So just now I have mentioned about one band or octave band. Okay, this one actually one octave band. This one is 1/3, and the last one we have 1/12. Sometimes, depending on the purpose or the intention of the measurement, this one more on research purpose. The related parties are using this 1/10 or 1/12 octave band. Okay. However, for the common measurement purpose, we use either 1 octave or 1/3 octave band. Okay. So based on my own experience in handling construction noise itself, in terms of the management, in terms of the measurement, me and my team using this 1/3 octave band. Okay. All right. Okay, the next one we are going to cover on types of noise. Okay. However, okay, is everything okay? Do you need break for a while? Okay. Or you just want to proceed? I think it's better for us to have a short break. So we will continue. Is it clear?
Okay, Doctor.
All right. Okay, thank you. So we will continue to the next subtopics for today's class, which is on types of noise. So this is basically the classification of noise types, as I mentioned previously. Okay, I would like to share to all of you different types of noise or different classification. Okay, the main classification of noise we have outdoor, like the first one, outdoor. And then the second one we have indoor. Okay. So most of the time we will refer outdoor noise as an environmental noise. Okay, this one. And the second one we have indoor, which mostly related to the building or any space. So this one more on indoor noise, right? Okay, for both outdoor and indoor noise, we have this classification or subtypes. Okay. For the first environmental noise, we have these three subcategories of traffic noise, construction noise, and also neighborhood noise, right? So for the purpose of our topics, for the purpose of this class, we are focusing on this one, construction noise. Okay, on this right side, we have several sub-explanation or sub-list here. This one is actually more on the related application or related guidelines for each of these noise category. Okay, so throughout this class, we are going to look at this one. Okay, on this category of noise, focusing on construction noise, right? Okay, just for additional information, the second classification of noise we have indoor noise. So this one relate more on the space or enclosed space within a building. Okay, for example, I have mentioned related to the indoor noise or indoor building noise, which is for the classroom, office, or hall, where we have echo problem. So that issue or that case will categorize under this one. Then the same or the similar situation also can happen in manufacturing industry. And then indoor noise building also will generate occupational noise. Okay, you need to differentiate that environmental noise relates more for the surrounding itself, will affect the residents. Okay, however, for the occupational noise, okay, it's related to the occupation itself. Okay, for example, in construction site, we have construction workers. So any problems related to the condition of the workers itself due to the construction, due to the noise itself, so that one will be categorized as occupational noise, right? For example, we have situation or we have condition of noise-induced hearing loss, okay, NIHL. Okay, this one will affect the construction workers or anyone within the proximity of the construction site. Okay, so NIHL will be related to the occupational noise, the workers itself. We look at here, we have workers with part of the affected party due to construction noise. All right. The next one, this is the types of noise based on the characteristic of noise itself. So in overall, we have three types of noise characteristic or type of noise depending on the characteristic of the noise itself. First, we have steady type, steady noise. And then second one, we have non-steady and pulse. All right. Okay, each of these category or type of noise based on its characteristic have two sub characteristic for each of this one. Okay, for example, here we have steady noise. It can be divided into two subcategory. The first one, constant, and then the second one, intermittent. So later on, I will share for the next slide. I will share on the diagram of figure representing each of these types of noise characteristic, noise what we call noise category. All right. So for example, steady noise, we have constant noise. Constant noise can be generated by pump, electric motor, or engine generator. So most of these equipment or most of these machineries will produce or will generate steady and constant noise. Okay, as we compare to the air compressor. Air compressor will create or will generate this kind of noise, intermittent. Okay, and on the other side we have non-steady noise. It can be predictably, which is fluctuating, and then we have large irregular fluctuation of fluctuating. It is two subcategories of non-steady noise. And the example, there are example for each of this category. And you need to know that in terms of noise types or characteristic or classification, we also have impulse, which can be categorized in impulse, simulated impulse, and then we have isolated impulse. Right. So as an example, isolated impulse can be generated through hammer blow, right? So that one, for example, relates to the construction activities. We have piling works using drop hammer. Okay, that one can be considered as impulse isolated, right? Okay, so this is the visual or the illustration for each of these noise type. Here we have the first one, we have the figure for steady noise. So basically the top and bottom part are to represent different subtypes for each of the noise. Okay, so here we have small variation of the steady noise illustration, which represent this one constant, and the intermittent steady noise represented by this figure. We can see the difference in terms of its illustration. Small variation only have this smaller gap or smaller fluctuation within this noise graph. Okay, and then for the non-steady, we can see the fluctuation here. Okay, for this one categorized as predictably because it has an uniform pattern. Okay, as compared to the other one, non-predictable sound, which fluctuating. So that's why non-steady we have type. And again, for the impulse, this is the pattern. Okay, it has a sudden increase of the sound pattern, and it happened within less than within like 1 second. Okay, that's why this is the pattern. Isolated because if it's that if you can see here, there are some gap. Okay, that's why it being referred to the single impulse or isolated, not repeated, because it happened more frequent. Okay. Hopefully all of you can differentiate this one, okay, in terms of the types of noise based on its characteristic. All right. Okay, so up until now, that's all for the types of noise based on its, just now based on its characteristic and also its classification. All right. So the next one we are going to cover on construction noise intensity. Okay, this one is the what we call introduction or overview, which later on will relate back to our calculation, right? Construction noise intensity. So we need to know this one. It is easier for us to have a good view what's actually the principle and the part of the calculation. All right. So construction noise intensity refers to the any sound energy transported through a unit area perpendicular to the specific direction. So it we relate to the area itself, which perpendicular in terms of the direction. Okay. So for the next slide, I will share on this illustration for this definition. Okay, so basically, noise intensity itself will be measured in unit of watt per meter square. Okay, meter square because it relates to the area itself. And then construction equipment or plant machineries can have intensity of more than 1 watt per meter square. And if we relate to the human capability or human hearing capability, the maximum intensity that human can hear is 1 watt per meter square, and the lowest will be 1 multiplied by 10 to the power of -12 watts per meter square. Okay, so this is just a information or additional information for all of us. Okay, it's not necessary for you to remember this one as long as we know the basic or we know the overview for what's actually noise intensity refers to. Okay, for the bottom part here for this information, this one is quite important because you need to differentiate between these two conditions or these two types of radiation. Okay, because noise intensity itself can be divided into two types. The first one we have spherical, okay, in terms of its surface area, and then we have hemispherical. Okay, so next one I will show this diagram related to both spherical and hemispherical. Again, I would like to highlight this one related to your calculation, right? Okay, for the description of both spherical and hemispherical, we need to know this because it is easier for us to differentiate. Okay, most of the time or most cases, spherical radiation will happen or will occur for noise from pilot activities, okay, which originated from drop hammer, and it may be generated above the ground. Okay, if we try to remember back how actually the piling works will be carried out. So for example, if we use the drop hammer machine, okay, the hammer itself will be hanging here, okay, to set the column to the ground. Okay, so this one, the noise generation will happen on air, meaning that at the upper part, okay, so that one will be hanging above the ground. So that's why the radiation will be spherical because the source is hanging above the ground. Okay, in this situation, the height keep moving and the sources can be treated as a point source, eliminating noise in a spherical direction. Okay, as we compare to the other one, hemispherical, it happened or located on the ground, meaning that it touched the ground. So that's why the sound or the noise itself generate in this kind of shape of hemispherical. Okay. For the hemispherical radiation, the sound will be radiated in this shape of hemispherical. Most of the construction machineries are usually located on the ground. Okay, for sure, we have excavator, loader, compactor, roller, and so on. So all of that kind of machine will be located on the ground and it will produce hemispherical radiation of the sound. Okay, here we have example compactor, which compacting the soil, okay, and the sound will be reflected and hemispherical radiation will be formed. Okay, so in overall, that's the main difference between both spherical and hemispherical. So you need to remember this one, try to understand, okay, the basic difference between these radiations. All right. Okay, this is still on radiation for the construction intensity. This is the equation, okay, relates for both radiation. You can see here that intensity is represented by the symbol I, E, equal to the power and divided to the surface area. Watt, this one watt, so it's power, and will be divided with surface area for spherical, for sphere. So surface area for sphere is 4 pi r square. So that's why we have 4 pi r square here. Okay, as compared to hemispherical, we have on the bottom part we have 2 pi r square here. So this is the main difference in terms of the equation itself. Okay, so IP refers to the noise intensity, W represent some power or watt, and then we have distance. R represent distance, the given distance for each situation, right? So far is everything good? Can you understand this? Okay. Alright. Okay. So I hope that all of you can understand this, all of these, okay, in terms of the fundamental, in terms of the overview for each of the subcontent. So it's very important for you to understand all of these basic operational part so that you can apply this one later on. Okay, this is the visual or the illustration that I mentioned just now. This for the spherical radiation, we can see here that this is the filing machine, especially the drop hammer. So the noise basically will occur here. Noise will be generated at this point, hanging on the ground surface or ground level. So that's why for the pilot activities, we consider it as spherical radiation for the noise intensity. So this is the intensity for spherical radiation. Have R here is 10 and the blue for the power. And this is the hemispherical radiation, because most of the time, most of the cases for the every construction plant and machinery such as rotor, compactor, excavator, and so on, it will be positioned or it will be located on the ground. It touch the ground and the noise itself will radiated in this spherical shape. Hemispherical shape. All right. The next one we have, up until now, we have covered for the construction noise intensity. So the next one, we are going to continue for sound pressure level. If you are still remember, I have mentioned this one, SPL, during the earlier part, okay, for our class, SPL, represented by L. Okay. So again, SPL is the main parameter for some measurement or noise measurement. Okay, it's actually refers to the intensity of noise at receiver. Okay, anyone who receive or being disturbed by the noise can be considered as receiver. So some pressure level refers to that situation. And for the at the beginning, we use some pressure level in unit of Pascal. However, it's then converted to decibel. That's why currently now we are using this for dBA. Later, I will share you what's actually A refers to. So instead of Pascal, we are now using decibel because to overcome the problem in handling the huge range of 1 trillion numbers. If we still brush this unit, it's quite complicated for us to do the evaluation, to do the calculation and measurement, so on. Okay, so that's why Pascal being converted to decibel. So PA converted to dB, decibel. Okay, so I think if we aware on for this level, I took the brief overview. What's actually the need of the decibel? That's actually quite sufficient instead of us to explore in detail. Okay, we just need to know in brief why we need speed of Pascal. Alright, okay. In terms of the lowest and highest pressure, it's the value 82 by 10 to the power -5 is the lowest pressure that human can perceive of here, and 20 Pascal being the highest pressure. Okay. So this one can relate back to the human carrying capability. Okay. So related to the sound pressure level or speed F, we need to understand the loudness, right? Loudness itself is an evaluation of sound intensity or noise level by human ears can perceive. So this evaluation is actually subjective. So we need to know the concept of loudness because it relates to human ears or human hearing capability. And the evaluation of loudness itself will consider or will evaluate both sound level and frequency. So in order for us to evaluate loudness, we need to have this SPL and also we have information for frequency. All right. So basically a relationship between unweighted noise level ataupun sound pressure level in decibel and frequency we refer it as loudness curve. This one loudness curve, we have a few curve here represent the loudness curve of phone. Okay, refer it as loudness curve. Okay, so unweighted noise in dB is basically any sound. Okay, if you see later on, for example, we have 80 dB. So this is unweighted noise level. Because later on, I will share to all of you the weighting or the weightage for the sound. And we have several types of sound weighting. All right. Okay, continue to the loudness curve. If we look at here, the lowest one will be 0. Represent the lowest threshold that human ear can detect. Okay, this one is the lowest one. Okay, normal threshold of hearing. Okay, this is the lowest loudness curve of point. And then highest curve, 120 on the upper part here. The top curve we have 100 point. Okay. And any curve or any values exceeded the curve will cause thing in yes, which is more than 1 watt per meter squared. And just for additional information, between highest, this one, highest and lowest, there are some more curve with an increment of 10 decibel. But for the simplicity, we focus on the 20, 40, 60, and 80 curve. 20, 40, 60, 80, and also 100. And 100. Okay, this one. Okay. And another important information here, for each curve, the lowest point between 3 and 4 kilohertz is the most sensitive, okay, to human ears. So kalau kita tengok, if we look at here, The lowest one, 1,000, 2, 3, and 4. So within this range, mark the lowest curve. Okay. So this actually represents the sensitive region to the human ears, right? So I think that's all for the loudness and the loudness curve. Okay. Now we are still looking on the sound pressure level part or subpart, and now we are focusing on the sound weighting, right? As I mentioned just now, sound itself has its own weightage. Okay, so in overall we have several weighting or weightage. We have A, C, D, and Z, right? So these five are the main or the common weighting for sound. Each of these weighting or weightage has its own purpose, right? For example, the most important one that we need to remember is A. A weighting is sound weighting because it's represent the human ear sensitivity for all range of frequency. So we are going to use this one, B weighting or A weighting. Okay, for the B weighting, it's mostly used for the musical purposes. Okay, for the intermediate tone levels. Okay, just for our additional information. Then, for the C sound weighting, we have low frequency sounds. For example, construction plant and machineries, which most of the time can't be heard but can be felt by human ear. So, in long term, it will affect the human capability. And the next one we have D, represent the baronetic noise with significant and high level of noise generation. And Z should be the baseline. We had no weighting, 0 or no weighting. It's just a baseline. Okay, so from all of this weighting, the one that important, okay, I mean not all of these are important. However, for our purpose, for the purpose of our topic, we are going to focus on A. So later on, you will notice that we will have DB and also DBA, right? So any sound with A at the end, it's actually represent the decibel in A weighted value, right? So that's how we are going to refer this DB and DBA. Okay, so far is everything okay? I need to always ask all of you so that I know that all of you still able to follow the class, right? Is everything okay so far? Okay. So we have some more content left, right? Okay. Thank you for your response. And all of you can understand this, okay? Are able to do the calculation later on. Okay. So continue to this sound pressure level in decibel A. Okay. So again, sound pressure level in dBA is an important unit or important item to represent yes sensitivity. So dBA is basically for human hearing capability or human ears, right? Some pressure level dB in each frequency spectrums need to be corrected using correction factors. Okay, so meaning that if you have information in and then you need to use the correction using the correction table so that we can convert this dB to dBA. So later on I will share on this. And then related to some pressure level, another main item is that some pressure level from multiple sources can be calculated by logarithmic addition rule. Okay, you need to remember this one because if you remember just now on our early part, I have mentioned that sum itself cannot be calculated using common arithmetic rule because it involves log function. So that's why we need to apply this logarithmic addition rule. Okay, for example, source 1, okay, or source 1, we have 80 decibel. Second one, we have 75, and for the purpose of example, we have 3 value, 80, 75, and maybe 70. So in order for us to know its average value, or the combined value for these 3 sources, we can simply add these 3 and divide by, for example, 8 plus 35, 8 plus 35, 75, sorry, 80 plus 75 plus 70 divided by 3. This is wrong because we can simply calculate using common addition rule. Okay, we can use arithmetic addition rule. Instead, we need to use this logarithmic. Okay, so this is the question on how we want to calculate the sum pressure level from multiple sources. Okay, you need to know this one. Okay, maybe it will come out in your final exam. However, if we have calculation relates to this, you need to at least know the use of each formula because the related formula will be given in your final exam. Okay, but you need to know what's the function of each what we call of each formula or equation, right? Okay, so next one we are going to look this pressure table. Okay, just now I mentioned that if you want to convert the dB value of the sum pressure level to dBA, then you need to apply these A weighted fraction values. Okay, for example, again, if you have 80 dB, you want to convert to dBA, then you need to apply this what we call A weighted fraction table, or sorry, fraction value or fraction factor. Okay, so because all of these values for the fraction are given accordingly based on its frequency band or frequency region, starting from 20 Hertz up until 20 kilohertz. Okay. For the purpose of different ears or human hearing capability. So we need to deduct all of these values. Okay, so that at the end we are able to convert from dB to dB. Okay, just apply this table, and it's already established like this. Okay, we just apply the values. Okay, the next one relates to the construction aspect propagation, which is one of the main subtopic relates to this topic. Right. So in reality, we already know that most sound sources from construction equipment can be considered as one source, right? Each source has its own power, acoustic energy, in terms per second or watts. This one is in terms of its unit. Okay, so power itself we call it as some power level. Some power level. We need to differentiate with the some pressure level, because some power level most of the time we will regard this as LW. Just now we have LP. Up until now we have LP. So these two you need to differentiate very well. Okay. so that it's easier for you to come up with the correct values for the calculation. Okay, so some power level of each individual machinery will be measured at 1 meter distance from the source known as some power level. This one, LW. So any measurement close to the instrument itself or close to the machinery itself will be known as some power level instead of some pressure level. Some pressure level, most of the time we will measure it at a distance. Okay, from the there are specific distance between the source and receiver. Okay, the most common one is between it's around 10 meters. Okay, as compared to some power level which is only 1 meter. Alright. Again, this is another what we call another important equation or formula that you need to aware, that you need to know. Okay, on how we want to calculate what we call some pressure level based on the some power level. Okay, or interchange or it's vice versa. So this is this equation showing the relation between some pressure level with the some power level. So, for example, for the purpose of what we call assignment or final exam, if you ever have this kind of this related equation related to this one, okay, it's given that the value is LW, and then you need to use this formula to calculate the some pressure level. Okay, and again, it's depending on the condition or radiation for each of the sound intensity. Okay, we have just now I have explained that we have two radiation conditions, spherical and hemispherical. Okay, so you need to identify properly. Okay, just let's say we have finding. Okay, then for sure we need to use this formula. File machine for the filing work. If you have excavator, compactor, roller, and so on, then you need to apply this second equation. Okay, and how about the third one? The third one, most of the time we don't have any information related to the sound power. So we only have the information in terms of the sound pressure level and also the distance. R represent the distance. Okay, so this one mostly involves two types of machineries, and we have been given information of what we call related to equipment in terms of its sound pressure level and also distance. Okay. However, this the first two spherical and hemispherical equations are the main equation, okay, that we need to know, that we need to remember. It's still okay if you do remember, as I mentioned just now, it will be given in the equation if you have an equation related to this. Okay, however, you need to know the application. You need to know which situation to use the suitable formula. Okay. All right. So far, is it okay? Okay, all of you. All right. So I hope that I hope that you can understand all of this since it's relates both principle and also calculation. All right. So the next one, I think this is maybe last or second last for the subtopic or subtopic for today. All right. Now we are going to look at on factors influencing propagation. All right. So these factors again will relate to our calculation. So in our graph we have here, if we look at this diagram, this figure, we have here non-sources. Right. For this case, this is an activity for site preparation for construction project. We have lorry and also excavator here. Okay. And then we can see that on this part we have source, and then on the left part we have receiver. Meaning that the nearby resident living close to the construction site, and in between we have barrier. Can call it as noise barrier in between the transmission part of noise. So from source receiver we have this transmission part, right? So this brick wall or noise barrier expectation, we try to cut the transmission or try to reflect in the transmission part. Okay, relates back to the factors influencing the propagation. We have here barrier. So barrier is one factor that influences the noise propagation. And then we have the factor for reflection. Once the noise part has been reflected to the surface, so we have this reflection factor for reflection. And then if there are any factor for absorption, one will be correction for absorption. Okay, that's why we have atmospheric factor here, and vegetation factors that influence the noise propagation. And another thing we have this one, temperature effect, ground attenuation. Okay, so basically for the noise propagation itself, there are several factors that influencing or affecting. Right, so we are going to briefly look at on each of these factors. All right, for the atmospheric absorption, it varies strongly with the frequency of sound wave and temperature humidity, which to a minor extent atmospheric pressure in the air. That's the first factors that may influence propagation. And it is greatest at highest frequency and also in the hot dry air. Okay, this factor will highly influence the propagation in this condition. Right? Then atmospheric pressure increases linearly with the distance, and it will become more important as propagation path length increase. So it will be linear in the relationship with the distance. Okay. So the greater the distance, the higher the atmospheric pressure. And then in some cases where there's some propagation close to the ground for distance between source and receiver, which is less than 100 meters, this factor is not really significant. Okay, it becomes insignificant, which is essentially independent. Okay, so that's the solution, that's the condition, right? And then this one for the atmospheric absorption factors. The next one we have ground attenuation, okay, as the factors that may affecting the propagation of noise. Okay. Most of the time, attenuation due to ground surface is caused by acoustic energy loss by reflection. Okay. For example, here we have a source construction site. This is the source, and then nearby we have hard surface or any wall. Okay, any hard surface that may reflect the sound. It will relate to these ground attenuation factors. Okay, when the source and receiver are both close to the ground, wave will be reflected from the ground and may interfere with the direct wave. So the direct wave will be disturbed due to the reflection. Okay, and then reflection from the ground can result in attenuation of sound level, and strongly depends on the type of ground surface. So ground surface we can divide it into two main types. The first one, hard and smooth surface, right? So again, all of these will be highlighted in our calculation. Okay, so hopefully all of you can differentiate each of these better so that it is easier for us to apply later on. Okay, because if we look at here, smooth and hard surfaces will give less absorption, whereas a thick grass may result in sound being reduced. Okay, because this is just I think most of us already know that hard surface for sure will reflect back the sound. If we have porous or small, we call yes, small and also porous surface, the sound may be absorbed. Okay, instead of reflect, it will be absorbed to the other side of the structure. Okay, so we need to know hard surface will reflect the sound and the soft surface may absorb the sound. Okay, that's the concept of reflection and absorption. All right. Okay, so this is one of the example based on the previous research. Okay, related to the ground attenuation, we have hard ground, mixed and porous ground. We can see that different clothing for each of these type of ground. Mixed ground, maybe they have the mix of hard and smooth ground or porous ground. Okay, so we can see that if we have porous ground, there is less or no reflection as compared to hard ground. Okay, it's just a relationship between the type of ground with the frequency. Okay. The next one, we have another factors that may influence the noise propagation, which is obstruction. Obstruction is basically refers to obstacle, any nearby obstacle, any nearby structure that may obstruct the sound propagation. Okay, so obstruction refers to any barrier. Most of the time, holding or noise barrier. It can be a building, concrete wall, or tree, maybe tree, intercepting the line of sight between source and receiver. So here we have the source, and then we have the receiver. So this obstruction or barrier exists in between these 2 points. Okay, it exists to cut the transmission path, right? In general, barriers contribute to decreasing noise level when the structure breaks the line of sight between source and receiver. So the main purpose is that we install the noise barrier or any obstruction in between or any existing obstruction with the intention to help in decreasing the noise level. So basically, noise level is one type of the noise mitigation. We try to cut the transmission path. By having this sound wave diffract around the obstacle to reach the receiver. So there is no direct transmission of sound. Okay. So that's another factor that may affecting the propagation. Then we also have vegetation attenuation. Okay. This one relates to the trees, okay, which have attenuate sound and calm the noise. Okay, for example, again we have the source. Here we have the sound source from the maybe the construction site, okay, from the load or even other equipment. Okay, here to the nearby houses or nearby residential or any other premises. So there will be the existence of trees. Okay, in between we have trees in between the transmission path. So this tree will have to attenuate the sound and calm the noise. So it's almost the similar concept with the barrier. Okay, the sound will be attenuated due to this pre-existing. All right, so relevant integration with the vegetation are only for depth of foliage of greater than 10 meters. So it has its own or specific factor for the what we call vegetation attenuation ability. Okay, so efficient trees and shrubs are thick with waxy leaves, dense evergreen foliage and branches that extend to the ground. So in our world, it's depending on the size of the trees, depending on the types of the trees and condition of the trees. Okay, so the bigger the trees will able to attenuate the sound more. Okay, so this table summarize the depth of foliage according to each of the sound frequency. Okay, in attenuating the sound that may influence the propagation. All right, so I think this is the last factor that relates to this what we call influencing or affecting the propagation itself. Okay. So mode of operation for the construction machineries, for the plant and machineries is another factor that another main factor of noise fluctuation at construction site. Okay, because as we know, machine does not always work at full capacity or full power during working hours. But it will take a break, we change the turning switch off or without turning off the engine while waiting for the loading and the idle power. Okay, so this one just what we call common situation on site. For example, again, let's say if we have earthwork, okay. So for the earthwork, depending on the scope of work, depending on the size of the project, so for sure there will be more than one equipment working at the same time, okay, working concurrently. Okay, for example, we have 2 excavators, okay, 2 dump truck or lorry, and also we have 1 compactor, okay, at one time, okay, which are working concurrently. So all of these machines will contribute to the total noise generation. Okay, however, for example, here we have 5 machine and machineries. Not all these equipment will work at the same mode at the same time, which contribute to the total noise generation. Maybe some of the equipment working at the full power while the other in an idle condition while waiting for the other to complete first. Okay, for example, for the purpose of loading and unloading the soil, maybe 2 excavator still excavating the soil. However, for the dump truck, maybe it will be standby mode or idle mode to wait for the this excavation activities to be done first. Okay, so that's why at the same time our machine does not work at full power. So we need to have this ratio of operating modes, mode, full, idle, or off. Okay, so we have these 3 categories. Okay, so that's the situation, or that's actually the factors related to the mode of operation. Not all the machineries will work at the same time. All right. Okay, so the next one, before we finish our today's topic, we are going to look at on this sound indices. So sound indices, or sometimes we refer to that to noise index, sound index. Okay, just a similar, just the same item. Okay, as long as we need to able to determine the right indices for each of the condition or for each of the situation. Okay. there are so many complex or so many detailed indices related to the sum itself. However, there are there are several main indices that we need to know, okay, especially for the purpose of this subject and for the purpose of construction noise management part. Okay, the first indices, the main one, for sure we need to know the sound pressure level. Okay, just now I already shared regarding the sound pressure level, or we can call it as SPL. Okay. I have mentioned this one quite several times so that all of you are able to remember this. Okay, LP. And apart from LP, you need also to know about LW just now, sample level. Okay, so that you can differentiate this LP and LW because it has specific equation or formula to calculate this, right? And apart from LP, sound pressure level, you need to know the extension or the detailed version of LP. Okay, we have A-weighted equivalent continuous sound pressure level. Okay. Why we call it as A-weighted? Because you can see here that it's already in here. Okay. It's still sound pressure level. However, it's in term of A-weighted equivalent continuous sound pressure level. Okay. In other words, we refer it as average value. Okay, average value of sound pressure level. Continuous, equivalent continuous sound pressure level presented by EQ. So, the other unit or the other term for this one, LEQ, we can refer it as LEQ, LEP, because E is actually the same thing with EQ. Okay, and some reference just use LP. Okay, so all of these indicator, all of these index refers to the same thing, right? Okay, that's the second one. The third one that you need to know is that L10. L10 is another indices that you need to know. It represents sound level exceeding 10% of specific time. So meaning that, for example, we have conducting noise measurement within 1 hour. 1 hour with what we call 5-minute interval. Sorry, 1 hour and 5 minutes. And then we have some, okay, just a simple example. We have 8 hours. Okay, 8 hours measurement. Or up until 8 here. Okay, so 8 hours measurement for the noise measurement. So by the interval of 1 hour, so for sure the noise will be increase and decrease and has its own pattern. So 10% is 10% out of these 8 hours. That's why we refer it as L10. And similar goes to the L90. It represents any sound level exceeding 90%, okay, of the specified time, which 90%, this one also another important index because L90 represent background noise or the ambient surrounding of the surrounding noise of the specific location. Okay, so we need to differentiate this and you need to remember this one. And LAF max is the maximum value. Okay, F basically refers to the fast mode. For your mention, we have fast and slow mode. Okay, so we have F and also S. Okay, for our purpose of this part, we are going to only focusing on this one, fast. Because fast are suitable to use for construction noise, traffic noise, and so on, any high dosage. For the slow response is basically for machinery stuff, okay, for the manufacturing, okay. So you need to at least know these sound indices, the difference between all these sound indices. Okay, I will share the figure to represent these indices. Okay, here we have Lmax, meaning that the maximum value within this measurement period. Okay, for example, maybe here we have 8 hours measurement. So, based on this overall measurement period, we have the Lmax here. For this is just example, train pass by. And then this green line, okay, represent the average value of equivalent continuous some pressure level. Okay, that's why we call it LEQ, LEEQ. It says at the end of this one, it's already mentioned BPA. So it's okay for us to just refer it as LEQ. Okay, LEQ, LET, or LP. Okay, so this is the illustration. Sorry, do you have anything to ask? Okay. Okay, so far is everything good? We are all
Okay, Doctor.
I have some questions. We have Denison. Denison, you have anything to ask? Maybe Andy, Lisa. Okay. So we'll continue. Just a few more. I think this is the last part. Okay. This is another figure to illustrate the indices just now. Okay. This is the sum pressure level, the red colored line to represent the sum pressure level measured within the measurement period. And this is the actually the region for LPEQ. Right? So hopefully you can understand this one. Okay, so sorry, Denison, can you mute yourself? Right. So as long as it's clear. All right. Okay. Similarly, this is the again the sum indices in the illustration based on this figure. This is the L10 index. L half of the sound pressure level. The average, the half L10, L50, and this one is L90. Represent the ambient or background noise level. Okay, this is just an illustration for the previous indices that I have explained, right? Okay, so I think up until now, that's all for today's class. Okay, so far is everything here?
Hello? Yeah. Huh?
Is everything good? Okay. All right. So, content. All right. So that's all for today. Actually, that's all for the second part of construction noise management. So again, hopefully, I hope all of you can refer to the previous note and also this note, which is I will try to upload it as soon as possible together with the video, okay, for your revision, so that you can try to understand the detail. Okay, you can try to grasp the main content or main information for this topic. Okay, do your own revision. Okay, throughout your revision, if you have anything to clarify, anything to ask, just contact me. Okay, I will try to assist you with my best, right? So with that, I think that's all for today. Before we dismiss, please scan your attendance using this QR code, right? So please scan the right code for each of the section, for each of the class, MKAM1133-01 and SKAB5133-01. Okay, for those who have scanned your attendance, thank you for your participation. Hope to see you again next week. All right. Assalamualaikum and very good day.